Hey guys, we're going to check our understanding for the college activity that looks like this, where we did the standard deviation by hand, and the height activity, where we're comparing two box plots. Okay, so let's do it. We took some notes. I think everything went pretty good. I feel pretty good about all this. It says calculate the mean. So we're going to add all these numbers up. All the numbers, and it looks like we have 9 cities, and we're going to divide that number by 9. Okay, then the median, we're going to order them least to greatest. It looks like they're already listed least to greatest, right? And so we'll work our way to the middle. So this has to be our median. And these are in annual rainfall in inches. Okay? Now, would you use the mean or the median to summarize a typical rainfall? So, we're definitely going to use median. And the reason is because our distribution is skewed left. So anytime it's skewed, meaning, see how it's kind of not here? It's not this. So it is not symmetrical, so therefore we're going to use the median. The distribution is skewed left. We also might have some possible outliers as well. Okay? So now it says, what is the standard deviation of these 9 cities? And here's the most important part that maybe you missed. And what does this mean? Well, standard deviation means that the annual rainfall for a city typically varies by this number, however many inches it is when we calculate it, from our mean of. So let's see, what did we get here? I got 34.9 inches. So the mean was 34.9 inches. So that's how far a typical city's rainfall varied from that mean. So now let's figure out our standard deviation, right? So I asked you one more time to calculate it by hand because I think it would be nice one more time. So if our mean is 34.9, right? Then I'm going to take this number minus 30.9. Excuse me. 34.9 minus 8.2, 26.7. And then we're going to square it, right? Minus 34.9, 24.6, and we're going to square it. And we're going to keep going and keep going and keep going until we get our final answer, right? And then we're going to add it up. We're going to get our sum, right? And then we're going to divide by 9, and we're going to get a number, okay? And that number should be around something between about 14 to 16, okay? Now, we're going to use the software to check this number. But again, I'd like you to do it by hand because it helps you understand what it means. Okay, so let's use some software now. Let's see, we'll go to Statlet. Yep, okay. And this is definitely a quantitative variable 1 group. So this is our rainfall. And we can put in our values here. So 8.2, 10.3, 33.5, 39.1, 40.5, 41.9, 42.4, 44.9, 53.7. Okay, so let me just verify those numbers. 8.2, 10.3, 33.5, 39.1, 40.5, 41.9, 42.4, 44.9, 53.7. Begin. Okay, so yeah, we definitely got, I'm just going to do a little sneaky thing here. Okay, insert this picture. Here are summary stats that we got from the program. And I'm just going to stick them here because I like them, right? I'm like, oh, that's nice, right? It looks like I got a number that's pretty close, somewhere between 14 to 16. So depending on your calculations and depending on if you divide it by 9 or you divide it by 8, it should be close to that. But that's how we calculate standard deviation by hand, okay? Now we're going to check our understanding for the next one, but I want to write down some ideas. And again, these ideas are to help students that really maybe struggled and need an extra check for understanding. So the important ideas here, the first learning target of this lesson were measures of center. Okay? And there's two main ones. There's actually more than these two, but the main ones are mean and median, okay? The mean is usually what we call the average. And we've been calculating this by hand. I think I've told both classes. We call it X bar, and it's equal to all of our X values added together, which would look like that, the summation of all the X values divided by N. Now our median is merely the middle value. Sometimes if there's an odd number, we can just find the middle number. Other times we have to average. We have to add up and divide by 2 the average of the two middle values. Okay, so I think most students are getting this basic idea. And we've seen this in other classes. So learning target number 2 would be, what are measures of variability? This is more of what we focused on today. So how does somebody measure their variability? Well, the first way was just your range. So your range is your maximum number minus your minimum. And we discussed how it doesn't really tell you a whole lot. It just tells you the really highest number and the really lowest number. So standard deviation is actually quite a bit more useful. And again, it's the square root of the summation. And we took our X value and subtracted it from the average and squared it, and then divided by N minus 1 is how the computer does it. Now in our next class, which was in the second half of class, we also did the IQR, right? And so in that one, that's our inner quartile range, quarter 3 minus quarter 1, which was not really focused on. But the real focus of our lesson today is understanding what it means when we say, what is the standard deviation? So the standard deviation is whatever your context, the average number of shoes you have or the average number of rainfall you get, the typical, give the context. And it is the typically, how much that context typically varies by whatever the standard deviation value is from the mean of whatever your mean is. So if you think about this, this is the script that I use down below. All right, the context, the annual rainfall for the city typically varies by whatever the standard deviation is, that was 14 to 16 inches, from the mean of X bar, from the mean of 39.4. So that's how we describe or interpret the standard deviation value. All right. Now, last learning target. So let's give myself a little bit more room here. Learning target 3 of this lesson was we want to understand and notice. So we noticed in our activity that the mean and the standard deviation are greatly affected by these outliers. So it is for this very reason that we call them non-resistant. They do not resist change. They change a whole heck of a lot. Even just one number can change them wildly. So for that reason, when we see we have possible outliers and or we have skewed data in our distribution, then we want to use the median and our IQR instead of using the mean, okay? However, if we do not have outliers and it is not skewed, so when the data is symmetrical, right, we're going to go back to using what we're used to. We're going to use the mean to describe center, and we're going to use the standard deviation to describe center. Thanks for joining us, guys. Check us out on the next video for the second check your understanding of the day.